Bismillahirrahmanirrahim. We proceed to example 1.8. Given the function fx is equal to set x, gx is equal to x squared plus 4. Okay. Find the composite function g compose f and f compose g. State the domain and range of each of the following composite function. Okay. So our fx is equal to set x, right? Okay, and we know that, okay, for element in the set must be positive, right? Which is, we know that set 4 is equal to 2. Okay, how about negative set 4? You will get mad error. Okay, so automatically we know that any element, okay, in this set must be x greater than equal to 0. Okay, automatic we know that domain f is equal to 0 to infinity, right? Okay. And this one, okay, fx is equal to x, okay, greater and equal to 0. Okay, means that, okay, y greater and equal to 0. So automatically we know that range f is equal to 0 to the infinity. Okay, so our graph should be like this one. Okay, so this one y and this one x. Okay, compulsory to write this axis. Okay, y and x axis. Okay, you will get 1 mark. Okay, for the labeling of axis. Okay, next gx. Okay, gx is equal to x squared plus 4. Okay, x squared plus 4 here. This one is the quadratic function, and we know that for the quadratic function here, there is no interval of x, so automatically we know that domain g is equal to real number. Okay, what is a real number? Negative infinity to positive infinity, right? How about range? Okay, range g. Okay, how to find range here? So look at here, x squared plus 4 here. Okay, you have to do the computing the square, but there is no element of x here. So automatically we know that x squared plus 4 is equal to x minus 0 squared plus 4. Okay, so our minimum form is equal to 0 to 4. How do we get 0? X minus 0 is equal to 0, x equal to 0. So that's why we get the 0, 4. Okay, so our shape of this picture should be here. When x is equal to 0, y is equal to 4. So this one is a y, this one is x, and this one is equal to 4. Okay, so our graph start with, okay, y-axis equal to 4. So automatically we know that range g is equal to 4 until infinity. Okay, settle, find the domain and range for the df and rf, range f, and domain g and range g. So this one is our keyword, right? Okay, so you want to find the g compose f. Okay, g compose f is equal to gfx. Okay, means that we do the f first, then g second. Okay, so this one is our x, this one is a fx, this one is equal to gfx. Okay, so this part is equal to f, this part is equal to g. Okay, so this one is a domain f. Okay, this one is a range f. Okay, and this one is a domain g, and this one is a range g. Okay, so from here to here, okay, this one is equal to g compose f ataupun gfx. Okay, and automatically we know that this one is equal to domain gf, and this one is equal to range gf or g compose f, right? So look at here, range f, domain g. Okay, this one is equal to range f subset d g, domain g. Means the element of range f also, okay, exists in the domain g here. Okay, so what is a range f? Okay, 0 to infinity. Okay, subset to domain g is equal to real number. Okay, which is a negative infinity to infinity. Okay, so look at here. Is there 0 in the between negative infinity? Yes, right? So automatically we know that range f compose domain g. Okay, so when exists, okay, composite function g range f compose subset domain g, Okay, means that there exists a composite function for the GF. Okay, so G compose F is equal to GFX. Okay, so we already know that we have to use the first F, right? So G, what is the F? F equal to set X, right? Okay, so G, what is the G? G is equal to X squared plus 4, right? So you have to substitute X squared plus 4, set X into this X squared. So you will get set X squared plus 4. This one can be cancelled. So you will get X plus 4. Okay, so X plus 4 here, this one is the, okay, straight line or line of the linear graph, right? Okay, so you want to find the domain G compose F. Okay, G compose F. Okay, look at here, D G F is equal to domain F. Okay, what is the domain F here? Domain F is equal to 0 to the infinity, right? Okay, so how about range? Range G compose F is equal to range G, right? Here. Okay, range G. What's the range G? Range G is equal to 4 and infinity. Okay, so here, okay, start with the 4 until infinity here. Okay, next, what should you do? You have to do the, this one is second first, right? Second. Second, F compose G, which is the FGX. FGX, G first, F second. Okay, start with the X here. This one is GX. And this one is FGX. Okay, so this one is G. This one is F, right? So this is domain G. This one is range G. And this one is a domain F. And this one is range F. Okay, since, okay, you want to identify which is the F compose G exists or not for the composite function. So range G subset to domain F. What is the range G? Range G is equal to 4 infinity. Okay, subset to domain F is equal to 0 infinity. Okay, so you want to check whether 4 included in the 0 to the infinity. So this one is start from 0, 1, 2, 3, 4 until infinity. So automatically exists, right? So we know that range G subset to domain F. Okay, here, this one, okay, F compose G, right? So F compose G means that F compose G, okay, from here to the here. Okay, start here and here. Okay, so this one contains of the domain F compose G, and this one contains of range, okay, F compose G. Okay, next what should you do? We want to find the domain F compose G. Okay, F compose G is equal to, okay, domain G. Okay. Okay. Before that, what should you do? We already know that there exists a, okay, F compose G, right? So before we proceed to find the domain, okay, and range, you have to find the F compose G. Okay, F compose G same as FGX. Okay, so what is G? G is equal to set X or X squared plus 4. X squared plus 4, right? Okay, so F is equal to set X. So you have to substitute right here. So you will get X squared plus 4 set. Okay, so this is our function for the F compose G. Okay, F compose G. Okay, so here we know that, okay, for the domain F compose G, okay, is equal to domain G, right? Okay, so domain G, what is the domain G? Domain G is equal to real number. Okay, real number. Okay, how about real range of FGX here? So this one, we have to find Y here. Okay, Y equal to X squared plus 4. Y is equal to X squared plus 4. Okay, okay, we want to find Y, right? So y squared minus 4z equal to x. Okay, and we know that y squared minus 4 must be greater than equal to 0. Okay, because we know that all elements inside the square root or the set must be in positive value. If not, we become math error. Okay, so y squared is equal to 4, y greater than equal to plus minus 2. Right? We find the y greater than equal to plus minus 2. And we know that, okay, for y here must be greater than equal to 0, right? So automatically, okay, okay, we get y greater than equal to 2 here. Okay, so for the range f compose G is equal to 2 until infinity. Okay, so this is our answer for domain F compose G, and the range F compose G is equal to infinity. Okay, done.